Now let us see how to find the domain of a given function. The domain of f of x is the set of all the possible values of x for which f of x is defined, that is f of x exists. So that is the meaning of domain, that is we have to find what are all allowed values of x. Now based on the given expression of the function, we have to consider some of the restrictions that will help us to find the domain. That is, first is wherever we see any denominator in an expression, it should be non-zero, right? Only then that expression will have a meaning. Secondly, if there is any expression inside the square root sign, then that expression must be non-negative. That means it can be 0 or positive, but it cannot be negative. Otherwise, the square root of a negative number is not a real number. And lastly, whenever we have a logarithm of say some quantity x, then the value of that x must be a positive number, because as we know that's the domain of logarithmic function. So using these points, we'll have to find out the domain of the given function. Now let us solve some questions based on finding the domain. Now here we have to find the domain of the function given by root of x square minus 3x plus 2. So we observe that the expression is there inside a square root sign. So therefore this immediately puts us on the restriction that the expression which is inside the square root sign must be greater than or equal to 0, right? That cannot be negative. So that means if we see the quadratic expression, we can easily factorize that into x minus 1 and x minus 2. So the product of these two must be greater than or equal to 0. Now to solve this, we use what is called as the method of intervals. In this method, we have to first ensure that all the factors are such that the coefficient of x is positive. So we see that in both of them the coefficient of x is plus 1. Right? Now what we have to do is, on a number line, we have to mark off those values where each factor becomes 0. Now if you consider x minus 1, it will become 0 when x is equal to 1. On the other hand, x minus 2 becomes 0 when x is equal to 2. Now after marking these values, on the rightmost side we have to mark off the plus, right? And as we travel to the left side, we have to keep on giving the plus or minus signs to those particular intervals. Now when we are crossing the value 2, for that particular factor, that is x minus 2, we have to check its power. Now here we have just x minus 2, that means it has power as 1. And if the power is an odd number, which is the case here, then we invert the sign written what we wrote previously. So initially we wrote plus, therefore now after crossing the value of 2, we will write it as minus. Now we go further on left side, and here we cross the value 1. Now once again, for the factor of x minus 1, the index was 1, which is an odd number. So therefore we once again invert the sign and write it as plus. Now if the indices, that is this 1 and 1, suppose in some place these indices are say even numbers, then we will not change the sign as we go from right to left. Alright. Now after marking of these signs, we have to look at the required inequality. That is, our inequality is for greater than or equal to. Alright. So since we have greater than, we have to include all the regions which have plus sign in them. Right. And the equality will be held at these particular junctions where the factors are becoming 0. Alright. So therefore here if we write down the allowed values of x in a combined manner, we see that the first region is from minus infinity to 1, right? Or another possibility is that it's the region from 2 to positive infinity. So x can belong to this particular interval only for that function to be defined. So therefore the domain is nothing but x must be among the values of either of these two regions as shown here. So that's the domain of the function. right? Now let's see another example. Now here we have to solve the given inequality. That means we have to basically find out the values of x that satisfy this particular inequality. So which is analogous to finding out the domain of a function, right? Now if you observe, this inequality involves the modulus function on left hand side, right? And there is a greater than or equal to, that is the sign of inequality. Now just to recollect quickly, if we have the modulus of some number less than or equal to a, then that number has to lie between minus a and plus a. This is for the less than inequality. Now what if we have modulus greater than a certain number e? So in that case x can be greater than or equal to a, or x can be less than or equal to minus a, isn't it? So therefore based on this, now let us solve the given inequality. Now here we have greater than 2, greater than or equal to 2. So therefore we have two possibilities. The first is the required quantity which is inside the outer modulus sign has to be greater than or equal to 2, or that same quantity has to be less than or equal to minus 2, right? These are the two possibilities. Now therefore here we have to simplify now. So taking minus 5 on other side, that gives us 5 plus 2 is 7, or here taking 5 on other side, we have 5 minus 2 is 3. Now if you see the first possibility, once again we have some modulus greater than or equal to a number, that is 7 here. So that means we must have x minus 1 greater than or equal to 7, or we must have x minus 1 less than or equal to minus 7. So these two conclusions are derived from the first part. Now or we have already the second part also now, that is if mod of some number is less than 3, then that means that particular number or quantity must lie between minus 3 and 3, right? So this is the other possibility. Now therefore solving further, here we have x greater than or equal to 8, or here we have x less than or equal to minus 6, isn't it? And here in the last possibility we have x minus 1. So to get rid of minus 1, we add 1 throughout the inequality. So therefore we will get minus 2 less than or equal to x less than or equal to 4. So that means these are the three required regions to which x can belong. So therefore here we write x may belong to. Now if we want to show it graphically, so that normally we write the three sets in order. Here we have x greater than or equal to 8, right? Then here we have x less than or equal to minus 6, and the last is minus 2 and 4. So somewhere here we have minus 2 and somewhere we have 4. So x may belong to this. Of course there will be 0 somewhere here, right? So therefore the first set is minus infinity to minus 6. It will be closed at minus 6 because that is also allowed. Or the second region is from minus 2 to minus 4, that's the middle region. Or the third region would be from 8 onwards towards positive infinity. So this is the domain of the required inequality. That means this is the allowed value of x for the inequality to hold. Now let us move on to the next question. Here also we have to find the domain of the function f of x given by sine inverse of log of x square upon 4 to the base 9. So here on high level, if we observe, it is the sine inverse function, and we know that for sine inverse of anything, that particular expression must lie between minus 1 to 1. So this gives us the restriction that the quantity log of x square by 4 must lie between -1 to 1. Now we observe that the log is taken to a number which is greater than 1, that is, it's not only positive but it is greater than 1, right? So therefore if we raise all the sides of the inequality as an exponent of 9, therefore we will get 9 raised to -1. Now since exponentiation and logarithm are the opposite processes, here we will be left with just x square upon 4 less than or equal to 9 raised to 1. So in other words, we have 1 upon 9 less than or equal to x square by 4 less than or equal to 9. And then multiplying throughout by 4 because we have to get rid of this 4 in the middle term. So therefore here we have 4 by 9 less than or equal to x square less than or equal to 36. Now when we take the square root, we have to be careful. It's not just plus or minus. The correct way of getting the square root is mod x. So therefore here taking the square root, here we have 2 by 3 less than or equal to mod x less than or equal to 6. Right? Now this means that modulus of x lies between 2 by 3 and 6. So therefore here one possibility is that see, x can be anywhere between 2 by 3 and 6. So this is on positive side, or on negative side it may happen that x lies somewhere between -6 and -2 by 3. So therefore the domain is that x can belong to the interval -6 comma -2 by 3, or it can belong to the interval 2 by 3 comma 6. Both are the closed intervals. So therefore that is the answer. That's the domain of this particular function.